Have you ever needed to do a quick string manipulation or data conversion in Logic Apps, but didn't want to spin up an entire Azure function just for a few lines of code? Good news! Logic Apps have a built-in inline code action that lets you run JavaScript, PowerShell, or C# scripts right inside your workflow. Let me show you how it works with a C# script. The inline code action is perfect for small operations where you need custom logic but don't want external dependencies. You're working with simple data transformations. You want to avoid the overhead of Azure Functions for tiny tasks. It works great when you need to format strings or numbers quickly, implement logic or calculations which are overcomplex when using Logic Apps Functions, but simple for using in Azure Functions. Parse complex JSON without multiple parse JSON actions. Avoid function app cold start for tiny tasks. Time for some hands-on practice. What if you need to implement a more or less complex logic with multiple conditional rules? For example, check email, phone number, some business rules. With inline code, you will get fewer logic app actions. One inline code action replaces multiple condition blocks. Let's begin by creating a new inline C# script action. So I'm going to add C# script inline action. As you see, there are also JavaScript code and PowerShell script inline actions, which you can use, of course. But I will focus on C# script code today. When the action is added to your workflow, you'll get predefined action code, which will help you to build your own code here. Let's have a look at what we have got with this action created. First of all, it's a function. It's a C# function, which is named run, and it has two parameters, one the workflow context and another one is a logger, which you can use to implement a login inside your function. And this function asynchronously returns a result. Result is a class defined within this file. As you see, the Logic app will get this file, a CSX file created and existing in the file system of your Logic app application. By the way, you can give a name to this file, your custom name, and actually I advise to give your own file name because it will help you to organize your code when you will create multiple inline code actions. And I saw that the result class is defined in this code block. So you will find this class defined in the bottom. It has only one property of string type message. And we will find creation of this result type object in the bottom in the return part. So this example generates some action and it gets access to the trigger data and takes the name attribute of the data sent over to the trigger and returns this name in the message attribute of the result object. I will replace this code with what I would like to implement. I want to remove the most part of the existing function body and we'll paste here the simple validation of the data which is sent over to the workflow, to the trigger of the workflow. My function will return is valid Boolean variable, so I will replace results here with bool type. The asynchronous type of the function will remain. We can remove this definition of the results because I don't need it. This line takes the data from the trigger. So the trigger outputs is a JToken object which gets the content of the trigger outputs. And then the trigger outputs body will be initialized to the profile. This profile will then contain the JSON data, JSON object with email, phone, and age attributes. What I need to do here, I want to check that email contains @. The phone number is precisely 10 digits long, and the age is 18 or over. And then checking these attributes is valid will be returned by the function. And I will also show you that I will replace the default name, validator, and as I said, the file will be named validator. And the last thing, I want a workflow to return the result of this inline code action. So in the response, I will specify that the response will contain the body of the validator action, which I have defined. Make note of the syntax, which is used here. With the actions and the action name, we get access to the action, and then in the outputs body, there will be a result returned by the action. So I put this into the body of the response action, and we can save the workflow. And now I'm ready to test it. I will test this workflow right here by using run with payload. And I will paste some example payload. This data look valid. This phone number is 10 digits. And when I run, the workflow returns true. I can also show you how it works when it fails. So for instance, if the age is 15, then the function returns false. Let's set it to 20. And the phone number can exceed 10 digits. It falls again. Or for instance, I forgot to place @ in the email address. False. True again. So this is a very simple example which shows how it's easy to implement a C# script code which will bring you a piece of logic which otherwise would, when implemented with Logic App Actions, would be more complex in the structure, will use more actions, where with this inline code action you have only one. And it's also much easier to reuse the same code in multiple workflows, multiple places within the workflow. And now let's go ahead and see more examples of what you can use inline code action in your Logic Apps workflows for. I've prepared a workflow with multiple inline code actions, and these are generate password. This will generate password with random chars, random symbols. The next one will parse date. The workflow will give it an unformatted date, and this will generate a date separated where the year, month, and date are separated with the dash sign. Extract emails. It will take a text, find email addresses, and present them in the output as a list of email addresses. Distinct strings. This will accept a text consisting of comma-separated words, and some words will be repeated in the text. So this action will produce the output of distinct words from this text. Calculating hash, it will generate a hash code of a text, CSV to JSON. The CSV text will be converted to JSON text. And the last one, mask sensitive data. And this section will accept a text which contains bank card numbers. It will find bank card numbers and replace them with asterisk jars. Let's go ahead and see how it works. I have an input text prepared, and I'm gonna send this data in the run with payload option. So this is the date which will be formatted. This one is a text where the email addresses will be found and extracted. The fruits element contains a text of words where the words are repeated. CSV data. This text is a CSV. The first part is the header. And then there are 3 lines. You see the new line char here. So this is a standard CSV text consisting of 3 lines of name, email, and score. Sensitive text element contains a text with bank card numbers. This will be found and masked. So I send this to the workflow, and let's see what is produced. It has generated a password. So this one is an action which generates just random password. Sometimes it's useful. The date was formatted with a separator. Emails, a list of emails taken from the input text. Let's check it out. So, for instance, this email address was here, and this one. So, I found all the email addresses and sent in the output as a list. Fruits attribute contains the distinct words from the text of repeated words. Hash was generated from the fruits element. Converted CSV. This is a JSON text, actually. Since it's given as a text in the JSON attribute, every double quote is escaped with a backslash. So it's accepted as a text content value to the converted CSV attribute, but actually it is a JSON. So we may simple convert it to regular JSON. The last one, masked text. So the text is just the same as original, but the bank card numbers were replaced by asterisks. This is just an example of what you can do with inline code actions in your workflows and how it will simplify your implementation. Because to implement this logic presented here, if you use standard logic app actions, your workflow will look much more complex. Or otherwise, you will have to use Azure Function to implement some piece of logic. Here you will balance between complexity of the logic and simplicity of the implementation. There are a few things to remember when you use inline script actions. The script runs in a sandbox. No external libraries like NuGet packages are allowed. However, standard core libraries are in the sandbox, and sometimes, depending on the logic that you implement, you have to adjust the namespaces, list of namespaces which you use in your script file. So some logic needs additional namespaces to be added. Remember this is important, otherwise your script will not work. Another limitation, script run duration. It's 10 minutes maximum. The output size is limited to 100 megabytes. For heavy logic, still use Azure Functions. Oh, and the last important thing, before you rush to try this, be aware that the inline code action is only supported in standard plan logic apps, not the consumption plan. If you're on consumption, you'll need to either switch to standard or use an Azure function for custom C# logic. So next time you're tempted to create a function for a tiny task, try the inline code action first. If you found this video useful, hit like, subscribe, and let me know in the comments what's your favorite Logic app hack or what you would like to hear about. Thanks for watching. See you next time. Goodbye.